Okay, now let's look at example 4. A 150-gram ball at the end of a string is revolving uniformly in a horizontal circle of radius 0.6 meter. The ball makes 2 revolutions in a second. What is its centripetal acceleration? Okay, so we have a string here, and at the end of a string is attached with a ball of mass 150 gram. And then this ball is revolving uniformly, okay, in a horizontal circle. So this is the horizontal circle with radius 0.6 meter. So from the center of the circle to the end of here is 0.6 meter. The ball makes 2 revolutions in a second. Okay, so the information here, revolution in a second, is actually the value for frequency. Okay, ingat semula, frequency here is the number of revolution per minute. The number of revolution per second. Okay, dia adalah per second ataupun kita panggil dia sebagai hertz, SI unit dia, ataupun per second. So, mana-mana information yang kita nampak ada revolution per second, itu adalah frequency. So, this one here is frequency, which is equal to 2 hertz. And then we have the mass, 150 gram, and the radius, 0.6 meter. And then what we want here is the centripetal acceleration, which is formula dia adalah sama dengan V square divided by R. Okay, so we have the radius, but we don't have the value for V, the velocity. So how do we find velocity? Based on the information that we have. Okay, so remember the formula for linear velocity adalah sama dengan R omega. So this one omega is the angular velocity. Dan omega di sini kita boleh substitute. Okay, kita boleh substitute dengan dua formula. Satu, omega adalah sama dengan 2 pi divided by t, which is in terms of period, ataupun 2 pi f in terms of frequency. So since kita sudah ada value untuk frequency, so kita boleh just gunakan this one, substitute kepada omega dekat sini, which is equal to 2 pi f. And then just masukkan, okay, value yang kita ada 0.6 times 2 pi times 2. So you will get the velocity 7.54 meter per second. Okay, and then boleh masukkan di sini 7.54. Okay, don't forget the square divided by 0.6. So you will get the acceleration equal to 94.75 meter per second squared. Okay, now let's look at example 5. The moon's nearly circular orbit about the Earth has a radius of about 384,000 km and a period of t of 27.3 days. Determine the centripetal acceleration of the moon towards the Earth. Okay, so what we have here is the radius and then the period. So we have the radius, which is in kilometer, and then we have the period of the moon, which is 27.3 days. And then soalan minta what is the centripetal acceleration, which we know the formula is equal to V square divided by R. Okay, so here example ni sama juga macam example 4 yang tadi. Okay, tetapi kita dibagi dalam bentuk period. So yang tadi adalah kita dapat information in terms of frequency. Now we are given the period. Okay. So now when we want to relate the velocity with the period, we know that velocity is equal to I omega. Dan omega adalah sama dengan 2 pi divided by t. So you can just masukkan 2 pi divided by t here. So we can get the value for the linear velocity. So just masukkan 384,000. Okay, so this one is in kilometer. Okay, jangan lupa untuk convert kepada meter. So apabila kita convert, kita akan letak exponent 3. Okay, because kilo is exponent 3. And then times with 2 pi divided by t. And then t here we are given in days. So you must convert to seconds. Sebab kita mau velocity dalam SI unit, which is meter per second. So 27.3 days times with 24, because one day we have 24 hours, and then 1 hour we have 60 minutes, and 1 minute we have 60 seconds. So just masukkan, you will get the velocity is 1022.98 meter per second. So boleh masukkan dalam formula ni. And then you will get the acceleration. Okay, tekan calculator, kamu akan dapat acceleration sama dengan 2.73 exponent negative 3 meter per second squared.